Hello. I've been watching a few videos lately, and flat earthers seem to be bringing out black swans and earth curvature and stuff like that. They're dealing with curvature in the direction that you're looking at. I decided I was going to explore side to side curvature and whether or not you could see the curvature and what that would look like scaled down to something that anybody would be able to replicate on the side of their house. First thing that I did was I modeled what it would look like in 3D space using OpenSCAD. This would represent the Earth. This ball here would represent your eye, and you'd be looking off in this direction. So this line here represents your horizontal eye level. This line represents the tangent line of the surface of the water that you're looking at in the distance. Next, I have this represents your line of sight directly in front of you. Each one of these represents what I would consider your usable field of view. According to Wikipedia, most people have about 120-degree field of view, so 60 degrees from your left and 60 degrees from your right to give you about 120 degrees. We can see more than 120 degrees, but by that point things get a little bit fuzzy and you can really only see blurry objects and whatnot. So that doesn't really count. So the next thing that we need to look at is the various objects in 3D space. So we have several triangles that are formed. This triangle here is your horizontal eye level directly in front of you. Then you have a drop to the surface of the water. This third line represents the closing of that triangle. Then we've got a similar triangle on this side, which represents the left side of your field of view. We've got this one that represents the triangle on the right side of your field of view. If we draw a rectangle, the top of the rectangle is your horizontal eye level, and the height of this rectangle represents the drop to the horizon. Then on either side, you would have some space between these edges of this rectangle to where the surface of the water is on either side. And that's the angle that we're trying to calculate here. So let's just look at the math involved. So the first thing that I want to do is I want to calculate the distance I can see if I'm standing 2 meters above the surface of the water. So if I'm standing at the beach and I'm standing on a rock or something, and my eye happens to be precisely 2 meters above the water where I'm standing, I should be able to see a distance of 5.048 kilometers. And the way I calculated that was using this formula here. Given the Earth's radius, and given my height above the surface of the Earth, if that forms a right angled triangle, I can calculate A. And A is calculated using this formula here. And the distance is calculated using this formula here. And I'm after the distance along the surface of the Earth, or the circumference of the Earth. This is not strictly needed, but I threw that in because I had copied it from another spreadsheet. The distance is line of sight distance, which is this distance here. And I calculated that using the sine of this angle here and the Earth's radius here, which should give me the same length as this. And that was calculated this way. And you can see that the distance is not quite as far as the distance along the circumference of the Earth. The surface of the water is going to be 4 meters below eye level at that distance. and degrees from eye level is going to be calculated like this. So essentially what I did was I calculated this angle, this distance, and this distance. I used different calculations to arrive at the same values. The next thing that I wanted to do is I wanted to calculate the distance and the angle to either side, which would be one of these here. So either this or this. So I needed to calculate this distance and this angle if this distance here is the same as this distance here. So if I'm looking at 5.048 degrees ahead to where the water starts to curve and starts to obstruct further objects, then perpendicular to that line of sight at 60 degrees on either side, I would have a distance of 10 kilometers. And the angle at 60 degrees on either side would give me an angle of 0.02269 degrees below eye level on either of those sides. So I'm essentially calculating this angle and this distance here. So this drop here is going to be the difference between this angle and this angle, which gives me 0.02269 degrees. If we want to put this into a context anybody can observe, let's say the side of your house is 10 meters wide. Let's say this represents the side of your house, which is 10 meters wide, and you're standing in the middle so that you've got 5 meters on either side of you. The distance that you would have to stand to have a 120 degree field of view would be 2.88 meters. And this is the formula that I used. And the distance to the side of the house, so let's say this is the distance to the house and this is the width of the house. We want to calculate this distance. We've got 60 degrees and we have these two which are known. This is the formula that I used here. So you've got a distance of 5.7735 meters to the side of your house. The drop on either side of the house from eye level would be 0.002287 meters or 2.28 millimeters. To put that in imperial terms, I took 10 meters and converted it to feet. I used the same formulas here to give me 0.0900537 inches or 1/11th of an inch. I use this formula to calculate what the radius of that circle would have to be, and I calculate a circle would have to be 12.6 kilometers in radius to equal the Earth's curve radius that you would see if you're standing at the beach 2 meters above the water and you're looking off in the distance. Let's say you're standing on a cliff, nice and high cliff. Let's give it 100 meters, which would be the equivalent of about maybe 300 feet. That would be the equivalent of 16 millimeters or 0.636 inches or about 1/1.5. That circle would have to have a radius of 1.78 kilometers. What would the view be in an airplane? Let's say, how high do airplanes travel? 35,000 feet, 37,000 feet, 10 point some kilometers. Let's go with 10 kilometers. So if you're flying over the ocean at 10 kilometers in an airplane, that would be the equivalent of 161 millimeters or a drop of 6 inches. The radius would have to be 178 meters. How high is the ISS? Is it 300 kilometers? Let's say you are 300 kilometers up. Now we're dealing with almost a meter drop on either side, and the circle radius would be 34 meters. So that's it for the moment. Thank you for watching. If you liked it, don't forget the YouTube troll, and I will see you again in another video soon enough. Bye for now.